Hey everybody, so these are the video solutions to worksheet 10.3a. We're going to be looking at the other trig functions besides sine and cosine in this one, and sort of as a word of warning, there's lots of different ways to approach these problems depending on how you want to define these trig functions. I'll try to make mention of the various methods in this video, but the key is going to be just finding a way that works for you, that makes sense, something that you can depend on, and kind of sticking with that. So with that in mind, number one, we're asked to evaluate the tangent at pi over 4. So kind of like we did with the last one, I'd really encourage you to kind of get a sketch so you can visualize what's going on here. So let's start by sketching this angle. So pi over 4 is a first quadrant angle, and the reference angle would be 45 degrees. So we'll go ahead and we'll sketch this on our xy plane. We've got our 45 degree angle going on here, so that's our pi over 4. 45 degrees, and we'll go ahead and we'll construct a reference triangle to use here. So there's our right triangle. This is a 45, 45, 90 right triangle, which means that if we were to label this, we would use, or we could use 2 for the hypotenuse, and since we're in the first quadrant, we'd have both positive root 2 and positive root 2 for the two sides. All right, so how do we apply this for the tangent? Well, the tangent we can think of in a few different ways. Tangent of theta, the most basic when we start off, and this is maybe the easiest way to do this, is to think of it as the ratio between the length of the opposite side and the length of the adjacent side, given some angle theta. We also talked about defining these trig functions in terms of x, y, and r. So the tangent is actually the ratio between y and x. And if we wanted to think about it in terms of trig identities, we could define the tangent of any angle theta as the sine of that angle theta divided by the cosine of that angle theta. So all three of these ways of thinking about the tangent will yield a correct solution. And let's actually go ahead and do each of those for this particular one. So let's try opposite over adjacent. So we're going to go to our reference triangle. So here's our angle, 45 degrees, or our pi over 4 that we're looking at here. So the opposite side, in this case, is going to be the square root of 2. And then the adjacent side would be square root of 2. So that would be the tangent. Also, we could think about it as y over x. So this is our distance y right here, the height of the triangle, and this is our distance x. Basically the same thing as the opposite and adjacent side. So our y would be the square root of 2, and our x would be the square root of 2. Clearly the same answer. And then for the sine, we could go to our reference angle, 45 degrees. The sine is the opposite over the hypotenuse, so it would be square root of 2 over 2. And then the cosine would be the adjacent divided by the hypotenuse, which would also be the square root of 2 over 2. In each of these cases, these three will simplify down to positive 1, which is the value of the tangent at pi over 4. So lots of different ways, whatever works for you. You don't have to do all of them, just find one that makes the most sense to you. I in particular like this one. All right, let's try and do the same thing with the secant. Actually, we'll leave this up here as a reference. So the secant, pi over 6 is our angle, so let's go ahead and sketch that. So again, we're dealing with the first quadrant angle here. Let's try that again. So we sketch our first quadrant. So here's our y and our x-axis. Pi over 6, if we converted that in degrees, that would give us 30 degrees. So we'll approximate a 30-degree angle of rotation here. And now we'll go ahead and we'll construct our reference triangle. So this is our 30, this is our 60-degree angle, and we know that we build this using the special right triangle. We'll call this hypotenuse 2. The shorter side is 1, and the longer side opposite the 60-degree angle is the square root of 3. So we can use this to help us evaluate the secant of this angle. So now let's go ahead and think about how we define the secant of some angle theta. So secant of theta we could think of as the ratio between the length of the hypotenuse, try that again, divided by the length of the adjacent side. Or we could write it as r over x, or we could use the identity 1 over the cosine of theta. Now we probably won't use this third one, the trig identities, that much, but it is helpful if you like to use the unit circle, for example, and you know what the cosine of pi over 6 is off the top of your head, well, you don't have to draw a triangle. You can just say, well, I know the cosine of theta, so the secant is going to be the reciprocal of that. So if you like to use the unit circle, you have that memorized. Using those trig identities are probably the easier way to approach this by putting it in terms of sines and cosines. But once we sketch these triangles, probably the hypotenuse and adjacent, or the r over x, will be the ones to use here. So let's think about that. So secant of theta. The hypotenuse is 2. The adjacent side is the square root of 3. Or we can think of it as r. So r is the length of the radius, which in this case is 2. And x is the base of this triangle, or the square root of 3. And if we look at 1 over cosine, again, this is, if you're thinking unit circle, you know that the cosine of pi over 6 is going to be the square root of 3 divided by 2. And in each of these cases, we'll end up with 2 divided by the square root of 3. Now, lots of times, especially with WebAssign, you're going to be asked to rationalize this. So to do that, we would go ahead and multiply the top and the bottom by root 3, which would yield 2 times the square root of 3 all over 3. And that would be a really nice exact answer for that. Okay, so that's how we would do the secant of pi over 6. All right, cosecant. So cosecant of 5 pi over 6. So we're changing it up a little bit now. We've got a second quadrant angle. So let's go ahead and draw the second quad. So here's our y and our x. And our angle of rotation, so 5 pi over 6. If we converted that to degrees, that'd be 150 degrees, which is 30 degrees shy of 1/2 rotation. So what we're going to see here is this angle of rotation is going to look something like this. There's our terminal side if we rotated it through. So that would be our rotation of 5 pi over 6, or 150 degrees. Now what we're interested in is this little reference angle right here. So since we're in the second quadrant, that reference angle is going to be 30 degrees, or pi over 6. And that's what we're going to use when we build our reference triangle like we did in 10.2. So since that's 30 degrees, that means that this is going to have to be 60 degrees. And we've got our 30, 60, 90 right triangle. So that would be 2. Our shorter side is 1, and our longer side is the square root of 3. However, since we're in the second quadrant, we know that our x's are negative and our y's are positive. So we're going to make this negative square root of 3. So this is the reference triangle that we're going to use to evaluate the cosecant. Okay. So how do we define the cosecant function? Well, the cosecant of some angle theta can be thought of as the ratio between the hypotenuse and the opposite side of that angle theta, the ratio between r and y, or 1 divided by the sine of whatever that angle theta is. So if we go through the opposite side of this angle, so now we're switching to our reference angle, the opposite side would be 1, where our hypotenuse is 2. So we've got hypotenuse is 2, opposite side is 1, or our r, which is this, would be 2. The y, which is this distance right here, is 1. Or we could look at the sine. The sine of this angle is going to be positive 1/2. So when the dust settles on this, all of these will simplify to positive 2, the value of the cosecant for 5 pi over 6. All right, and the last one is the cotangent of 4 pi over 3. So 4 pi over 3 is going to be a third quadrant angle, and this is definitely something you want to be comfortable doing, is identifying where these angles lie. So let's go ahead and sketch this out. So here's our y-axis, and then our x-axis. And we know that this angle is going to put us about 30, it's going to put us 30 degrees shy of 270. So it's going to be like this. So this is your 4 pi divided by 3 angle that we've rotated. And if we draw our reference triangle here, again, we're in the third quadrant, and in the third quadrant, our x's and our y's are both negative. Now this angle right here is our reference angle, and this is going to be 60 degrees, which makes this angle right here 30 degrees. So this is going to have the same triangle that we used in part C, essentially, except sort of flipped around. So we've got 2 for our hypotenuse, and this is going to be the shorter side is 1, the longer side is the square root of 3. And since it's in the third quadrant, both of these x's and y's will be negative. So for the cotangent, we can define this in a number of ways. One way we could define it as the ratio of the adjacent side divided by the opposite side, x divided by y, or the cosine of that angle theta divided by the sine of that angle theta. So if we use these three definitions along with our reference triangle for that reference angle, then our adjacent side is going to be -1. Our opposite side is going to be negative square root of 3. Or the x would be -1. The y, the vertical displacement, would be negative square root of 3. And the cosine for this particular angle would be negative 1/2. And the sine would be negative square root of 3 over 2. In each of these cases, we've got negative divided by negative, which would make it positive. We end up with positive 1 over the square root of 3. And again, like part B, especially for your online homework, you're probably going to need to rationalize this. So multiply the top and the bottom by the square root of 3, and that's going to give us positive root 3 over 3 as our solution. So that should do it for that one. So we covered a variety of ways that you could approach these, and really you only need to be comfortable with one of them, stick with it, and that'll be great. Okay, so let's move to question number 2. So for number 2, it tells us to use the given information to find the exact values of the remaining circular functions, given that we're told that the tangent of some angle theta is equal to 12 over 5. And this is the key piece of information here. We'll see is that angle theta is in quadrant 3. So what exactly does that imply? Well, the fact that we're in quadrant 3 tells us that our x's have to be negative and our y's will have to be negative. This is going to be particularly important when we set this up. So one way that we could go about doing this, if we need to, we think about what we want. We want to find the cosine of theta. We want to find the sine of theta. We know the tangent, so we want to find the secant of theta. We want the cosecant of theta, and the last one would be the cotangent of theta. Now again, as we talked about last time, there's lots of ways to define these. In this case, we're going to go with the x, y, r definitions for these, and we'll see in a second. But this is just one way to approach it. Cosine we know is x over r, sine is y over r, secant is r over x, cosecant is r over y, and cotangent is x over y. So this is what we want, and if we think about what we need, well, in order to fill all these in, we would need x, we would need y, and we would need a value for r. And if we had these three, then we'd be in really good shape. So what do we have? Well, we have this information about the tangent. Now, the tangent we know is the ratio between y and x. So we know that y, based on this, we could say, well, y is 12 and x is equal to 5. But this is not quite true, because we're in the third quadrant, which means the x and the y both have to be negative. And it's not something we'd normally see if we just looked at the tangent as positive 12/5, that both of those could have been negative and are in fact negative because we're in the third quadrant. So really what we need now is just a way to find r. So let's do that next. So we know that r squared is equal to x squared plus y squared, or that r squared is equal to -5 squared plus -12 squared. So we take the square root of both sides. We get r is equal to the positive square root of 25 plus 144, or that r is equal to the square root of 169, which is 13. So filling in now, we know that x is equal to -5, y is equal to -12, and r is equal to positive 13. With this information, we can feed this to our definitions and we can get our answers. So here's our solutions. So the cosine of theta is going to be x over r. The sine of theta is going to be y over r. The secant of theta is going to be r over x. The cosecant of theta is going to be r over y. And then the cotangent of theta is going to be x divided by y. And in this case, this would make them both positive, so we just have positive 5/12. So this would be our solution for the other 6 circular trig functions. Again, you can do this a number of ways. We won't do them all now, but this is a pretty dependable way of doing it. Again, don't forget this part right here. I pay attention to that quadrant so you know what's positive and what's negative. Okay, so for number 3, we want to find all angles that satisfy the equation secant of theta is equal to 2. Well, we kind of did ones like this in 10.2 with the sine and cosine. So based on that, let's go ahead and kind of recycle that information. So the secant of theta, we know we can think of in terms of sine and cosine as 1 over the cosine of theta. So this takes our equation into a slightly different form. We could say, well, if the secant of theta has to be equal to 2, why don't we write this as 1 over cosine of theta has to be equal to 2. Well, we could solve an equation for cosine of theta. So this last step is let's take the reciprocal of both sides, which is going to give us cosine of theta is equal to 1/2. So all we have to ask ourselves now is, well, when is cosine of theta equal to 1/2? And this is a type of problem we did a lot of in section 10.2, so hopefully we should be pretty comfortable with this. Again, we're going to find all angles, which means we need to account for the infinite number of solutions we may have here. All right, so how do we approach this? One way to do it is we could start by trying to visualize. So let's start by what quadrants would this solution be in? More importantly, where is the cosine a positive value? Let's forget the 1/2. When is the cosine positive? Well, we know that cosine of theta is going to be a positive value in quadrant 1 and also in quadrant 4. So that can start our visualization of these solutions. Before we draw this, let's also make note of what our reference angle is going to be. So the reference angle that we associate cosine and positive 1/2 with is theta equals pi over 3 or 60 degrees. So that's going to be the reference angle that we put in the first and the fourth quadrant. So now let's go ahead and get our sketch together. So when we sketch this, we're going to sketch the first and fourth quadrants because that's really all we need here. So we've got our first angle right here, which would be pi over 3. And then we've got our other reference triangle. So there's one of them. And then here's the other one. And again, this is, since it's a fourth quadrant, I'm going to write it like this. So this is our reference angle of pi over 3. But what we need to know is, well, what is that actual angle? So if we started at 0 and we rotated through to that point right there. So we're rotating a full 270 degrees plus another 30. So that's 300 degrees, or theta equals 5 pi over 3. Again, we could see that if we rotated 5 pi over 3 and then another pi over 3, we'd be at 2 pi right there. So those are our two angles. Theta equals 5 pi over 3 and theta equals positive pi over 3. Those will get us our two solutions there. So our solutions are, one is theta equals pi over 3. The other one is theta equals 5 pi over 3. Those are those two angles that we sketched right there in black. Now we want to find all solutions. So this first one, pi over 3, is going to repeat itself every 2 pi. So we're going to use the notational convention of adding on 2 pi times k, where k is any integer. And the same thing for 5 pi over 3. We're going to add 2 pi times k, where k is just some integer. And then these would be our solutions right here. So every possible angle that would satisfy our original equation, secant of theta is equal to 2, would take the form pi over 3 plus some multiple of 2 pi, or 5 pi over 3 plus some multiple of 2 pi. Okay, so the last one, number 4, we're going to find theta A and C. Theta is definitely the easier of the 3 to get started with, so let's do that. So theta, we'll do that first. So we know that theta and this other acute angle are complementary, meaning that they have to sum up to 90 degrees. So we know that theta plus 60 degrees has to equal 90 degrees, which means that theta has to be 90 degrees minus 60 degrees, or that theta has to be equal to 30 degrees. And hopefully you kind of saw that right away, but that's how we would get there. So there's our theta. So next step, how about A? Let's do that one next. So to find side A, again, as with a lot of these trig problems, there's definitely more than one way to approach this. So I'm just going to take one of many. I want to relate my known side, which is 9, with the side I'm trying to find right here, which is A. I also know that I've got these two angles right here, 30 and 60 degrees, that I can use because I know what they are. So is there any way that I could relate, say, 30 degrees with A and the known side 9, so that there's only one unknown value, namely A? In this case, the relationship between 30 degrees, A, and 9 is we've got 30, our opposite, and our adjacent side, which fits nicely for the tangent function. So we could say that, well, I know that the tangent of 30 degrees has to be equal to my opposite side, A, divided by my adjacent side, 9. And then we could just solve this for A. Let's multiply both sides by 9. So we get 9 times tangent of 30 is equal to A. And the tangent of 30 degrees, we could find that value in a number of ways. We've done it already, at least the methodology for solving these. It would end up being the square root of 3 over 3. So what does this tell us? So A would have to be equal to 3 times the square root of 3. Or if you'd used your calculator, which, you know, it didn't really ask for an exact value, so maybe you didn't need it. But if we had used our calculator, you would have gotten something like 5.2. Or another method, a way to check to make sure we're in the same place. So that's a solution for side A. Now for side C, we have got lots of options. We now know the value of 2 of the sides. We also know both of the angles, so we could use pretty much any trig function other than tangent and cotangent to find C. We could also use the Pythagorean theorem to find C. So we've got options. I'm just going to use the cosine of 30. So I'm going to relate C with 9 using the cosine. So the cosine of 30 degrees is going to be equal to the ratio between side 9 and the side C. So if I solve this equation for C, I'd multiply both sides by C, divide both sides by the cosine of 30. I'd get C is equal to 9 divided by the cosine of 30. Cosine of 30 we know is 1/2. Excuse me, square root of 3 over 2. So C is going to be equal to 9 times 2 over the square root of 3, or 18 over the square root of 3. Now again, we would want to rationalize this just to be careful, probably for homework's sake. And if we did, we'd end up with 18 times the square root of 3 all over 3, which actually reduces down to 6 times the square root of 3, which if we approximated this would be about 10.4. Now this is definitely not the easiest way to approach it. Probably the easier way to do this is to use the Pythagorean theorem. But we've probably done that a bunch, so thought we'd try something different. So that's totally up to you to find C. But you should have gotten a value like that anyway. Okay, so lots of options here, and if you find a way that you like better, that's great. Otherwise, you can use these methods we talked about here. All right, so that'll do it for the solutions in this video, and I'll see you all in the next one.